3 and 1. Okay. B is 2, -4. C is 5, -3. And then we have D, which is X and 0. Question 1.1. They want us to get the gradient of AC. So you're gonna say gradient is normally represented by a small letter m of AC, is the change in y, okay, over change in x, which is the same as y2 minus y1 over x2 minus x1, regardless of how you label this or how you use it. So I'm looking at AC, okay? If this is my x1 and y1, my x2 and y2, then I'm gonna have -3 minus my y1, which is 1, over 5 minus -3. Okay, so that's gonna give me a -4 over, this is gonna be 8. Because negative is gonna be a plus. So which means my answer becomes 1/2, but negative. So they're saying the gradient of AC is -1/2. All right, so then 1.2. 1.2, that's -3 minus 1 over 5. Okay. 1.2, they want us to get the equation of AC. We need to find the equation of the line AC. So I normally prefer using y minus y1 is equal to m into x minus x1. You could use mx plus c, no problem. So let me use the coordinates of A so that I have my y minus 1 is equal to my gradient, which is -1/2 into x minus -3. Okay, so it's y minus 1 is equal to -1/2 of x. When I open that, I'm going to have -3/2. Since this negative and negative will be a plus, and then this negative there. Then I'll move the -1 that side. So my y is going to be -1/2 x minus 3/2 plus 1. When we simplify that, what we get? -1/2 x. It's saying -3/2 plus 1, which is -1/2. That is -1/2. Oh Lord, what's happening? What is going on? Sorry about that, guys. Okay, so we're saying it's going to be -1/2. So that becomes the equation of the line that they want. Then 1.3, they're asking for the inclination. Okay, so one thing we know about the inclination is basically the angle that the line AC makes with the x-axis. Now I prefer the positive angle. So from m is equal to the tan of theta, okay? So if I was to call this my theta, just as my angle of inclination, for me to get that angle theta, I'll use the shift tan of m, okay? Where m is the gradient of that line. So since we got that gradient from 1.1 as -1/2, I'm just gonna punch that into my calculator and say my theta is gonna be the arctan of -1/2, okay? The arctan of -1/2. All right, and I'm getting -26.57 degrees. But remember what we said, we are interested in having a positive angle. So what we normally do, if we have a negative angle, just add 180. or you could get a half and then you subtract 180 minus the 26 like that. Okay, so if I have negative 26,57, I'm adding 180 degrees. I'm ending up with 153,43 degrees. Okay, so which means this is 153,4 degrees. This angle here, 153,43 degrees. Okay, so that is our angle of inclination. That is done. Then 1.4, they want us to get the coordinates or determine the coordinates of D if AC is a perpendicular bisector. So we have two words here. Number one, we have the word perpendicular. And then the other word is the bisector. Okay. So if AC is a perpendicular bisector of BD, which means this side is the same as this side, and M becomes the midpoint. Okay. If that is true, how do we get the coordinates of D? We need the coordinates of M. Nope, we don't need them. I'm gonna look at the gradient format where, let's say, if I get the gradient of BD times the gradient of AC, this must give me -1 according to the gradients of perpendicular lines. Okay, remember perpendicular simply means the lines are meeting or crossing each other at 90 degrees. So I think I can use that and say that the gradient of BD, okay, times the gradient of AC, I must end up with a -1. Let me just put it aside. Gradient of BD times the gradient of AC gives me -1. So since I know that the coordinates of B and D will be x0 and 2, -4, I can still apply my change in Y for BD. And then this is, I already have the gradient of AC, so I'll just replace it as -1/2. It must give me -1. Okay. So I'm gonna let my, I don't know, I can let this to be my x2 and then my, why not 1? Either way, doesn't matter. I'll call this 1 and then y1. And this is gonna be my x2 and then my y2. Okay. Then when I substitute in the gradient formula, I'm gonna have -4 minus 0 over 2 minus x. Okay, I'm multiplying this by -1/2 is equal to -1. Then I can divide both sides by -1/2. Okay, so that I have just -4 over 2 minus x is equal to just the 2. Guys, just confirm that for me. It's a 2. That's correct. Then from there, I could cross multiply so that I have -4 is equal to 2 into 2 minus x. I'll open up the brackets. My -4 is equal to 4 minus 2x. I can move the 4 that side. -4 minus 4 is equal to -2x. So -4 minus 4 will give me -8 is equal to -2x. Divide both sides by -2x, sorry, by -2. And then my answer is a 4. So which means that, okay, so we're saying x becomes 4. So which means the coordinates at point B are basically 4, and 0. Coordinates at D will be 4 and 0. All right. Then 1.5, they're telling us hence deduce that A, B, C, D height. So the question is not asking us what kind of shape it is. They're already telling us that indeed this quadrilateral is a kite. How do we deduce that? Now we know that from the properties of a kite that the diagonals, because it has this diagonal and this diagonal, that bisect at 90 degrees. But the question has already told us that, okay, that those ones are diagonal, or those diagonals are perpendicular to each other. So we can't use that kind of aspect. Okay, we cannot use that. The other property that we know about the kites is that the adjacent sides will always be equal to each other. So let's say AD is the same as AD, and then BC is the same as CD. I feel like I'm going to use that approach to deduce that ABCD is a kite. Okay, so I'll start by determining the distance AB. Okay, and then from my distance formula, I know that x2 minus x1 squared minus y1 squared. I know it's gonna kind of be lengthy, but I'll have to do it. Okay, when I do my substitution, okay, that's going to be -3 minus a 4 squared plus 1 minus 0 squared. When I punch that into my calculator, I'm getting 5√2 units. Okay, so if that is 5. Okay, guys, so now let's look at AD. Was that AD? Was that AD? Yes, that was AD, not AB. Okay, sorry about that. That's AD. And let's look at the AB. So it's going to be more or less the same thing. So I'm going to look at -3 and 1, and then 2 and -4. When I substitute into the distance formula, I'm going to have -3 minus 2 squared plus 1 minus -4 squared. Okay. When I punch that into my calculator, I'm having, that's a 5, and that's also a 5. All right, so I'm also getting 5√2. Then I'll go down and find the distance for CD. I have 4, 0 and 5, -3. Okay, so my CD, substitute that into the calculator, it's going to be 5 minus 4 squared plus -3 minus 0 squared. I punch that, I'm having just the √10. And then lastly, I need my distance BC. So with BC, I'm looking at 2, -4 and then 5, -3. Substitute that into the distance formula. So that's gonna be 5 minus 2 squared plus -3 minus -4 squared. Substitute that, punch that in the calculator, 5 minus 2 squared plus I'm saying -3 minus -4 squared, which also gives me √10. Then come down and say that since AB is the same as AD, and then CD is the same as BC, therefore ABCD is a kite. And the reason is adjacent sides. Okay, we are saying adjacent sides are equal. All right, so there we go. Adjacent sides are equal. So guys, that is question 1.5. Let's look at 1.6. They want us to calculate the area of ABD. Sorry, yeah. Area of ABD. So if you look at this, this is our point of focus. Okay. So since they told us that there was a perpendicular bisector, so we have a 90, which means AM is our height. Okay. I'm saying our height is going to be AM. And we also need to get the distance of AM. So we shall need the coordinates of AM finally. Then we need to get the distance BD. Yeah. Let's get the distance BD, then get the distance AM. Then we shall be good to go. So what I'm going to do, I'm going to start by finding the coordinates of M. Okay. So coordinates of M, we say this is 1.6. 1.6 coordinates of A using our midpoint. Okay. Midpoint formula, where we know that for the midpoint, we have x1 plus x2 divided by 2. Then do the same thing with the y. y1 and y2 divided by 2. So I'm going to focus mainly on the coordinates of B and D, to be my x1 and y1 and things like that. So which means my coordinates of M are going to be 2 plus 4 divided by 2. And then for the y, it's going to be 0, AM. Need to get the length AM. So if M, let me just say if A is -3 and 1, this is our aim. So the distance, I'm gonna say x1 minus x2 squared from the distance formula, y1 minus y2 squared. Okay, you have the right to label this as x1 and x2 in whichever format you're comfortable with. So that's gonna be 3 minus -3 squared, plus with the y, I'll have -2 minus 1 squared. And I substitute that into the calculator. I'm gonna have 6 squared plus 9, which is 3.5. Okay, that is our height, the distance AM. Then I also need to get the distance BD. Okay, so with BD, remember the coordinates of B are -2, sorry, are 2 and -4, and then D is 4 and 0. So what I'll do, I'll just say 2 minus 4 squared plus -4 minus 0 squared. Punch this into the machine. Okay, so that is 2 minus 4 squared plus -4 minus 0 squared. That is giving me 2√5. Okay, but since ABD is a triangle, I know that the area of a triangle will be given as a half times the base times the height. So our base is the BD, and then our height is the AA, as initially stated. So when I substitute, it's gonna be a half times 3 root 5, and then multiplied by 2 root 5. Okay. When I simplify that, that is 6. So 3 times 5, which is 15. I don't know, comrades, what you get in that side. So this is 15, but units squared. So that becomes our area for that particular triangle. So guys, that's what you have to do for question number 1. Okay, we move on to question number 2. They are telling us that in the diagram below, we have Q, which is 15, and M is the center of a larger circle, which touches both the x-axis and then the circle that is centered P. The circle with P has the y-intercept at A. Okay, we can see that. And it has an equation of this much. All right. If that is true, they want us to determine the equation of the circle with center Q in terms of x, y, and M. 1 mark. So guys, we know that the general equation of a circle is x minus a squared, and then y minus b squared is equal to r squared. Remember, the minus can be a plus, depending on the coordinates. Now, what I'm gonna do, I'm just gonna say x, since the 15 is positive, I'll change the sign. I'll say x minus 15 squared plus y minus m squared is equal to what is our radius? Our radius 8 units. So 8 squared is a 64. So that is 2.1.1. Then determine the value of m. 2 marks. Value of m. All right, so there was a statement that was given to us. Number 1, they told us that the larger circle touches the x-axis. That is important. Then they told us that the radius of the circle is 8 units. So if this is 8, which means even if I try to drop a line, okay, that is parallel to the y-axis, the distance there is going to be 8. And remember, the x-axis is also named as y is equal to 0. So which means we are counting how many units from the 0 line? 8 units to the center. So which means m is automatically 8 units. Okay, so saying m is going to be 8. Then if that is true, then they want us to get the length of PQ. PQ. When I look at the equation of circle P, the coordinates are 3 and 5, not 3 and 3. Okay. But the radius is 5. Since r squared is 25, which means the radius is 5. So which means from here up to there is 5 units. But we said from the circumference to the center of the big circle is 8. So guys, we don't need to find, or we don't need to use the distance formula in this case. We can just plus the radii. So 5 plus 8, and then that gives us 13 units. Okay, so if you have trust issues, we could probably use the distance formula just to affirm or confirm that indeed what we're talking about is correct. Okay, you get your 13 units there. Then if that is true, then they want us to get the coordinates of A. Coordinates of A. So since A is the y-intercept of circle P, and we already have the equation of x minus 3 squared plus y minus 3 squared is equal to 25. One thing we know about the y-axis is that x is always a 0. Okay, so what I'm gonna do, I'm gonna get that equation of that circle, x minus 3 squared plus y minus 3 squared. Okay, so that's a 16. And then I'll find the square roots on either sides. Okay, so y minus 3 will give me a plus or minus 4. Okay, I don't want to go that route of opening up, but you're still allowed to do that. You find the quadratic, and then you get your two values using the quadratic formula, all the factors. Okay, so my y is going to be plus minus 4 plus a 3. So the first y is either 4 plus 3, which is a 7, or negative 4 plus 3, which is negative 1. Now, the question wants the coordinates. It wants the coordinates of A. So since we have two values, you can see that the smaller circle is meeting the y-axis as at 2 points. Okay, so now we need to choose selectively, or we need to be very logical. Okay, so I'm going to say that my A is going to be 0 and 7. Since 7 is on the positive side. Okay, that is done. Then 2.1.5, they want us to determine the equation of a tangent to the circle with center P at point A. So one thing we know about a tangent is a line that touches the circle, that touches any graph at one point. And from our circle geometry, we know that a radius or diameter and the tangent will always be perpendicular. So since we have our coordinates of A, which is 0 and 7, we can get the gradient of PA. Okay, so we're saying gradient of PA. This is question number 2.1.5. 2.1.5. So gradient of PA, that's going to be change in y over change in x. So when I look at my coordinates, so I'm going to have 7 minus, okay, so 7 minus 3 over 0 minus 3. Okay, so 7 minus 3 over 0 minus 3, that's going to give me a negative 4 over 3. This is the gradient of the radius, okay? But the radius and the tangent, we said will be perpendicular, which means the gradient of the tangent is going to be 3 over 4. Remember what we said about perpendicular lines, that m1 times m2 must give us negative 1. So I'm just dividing negative 1 with this, give me 3 over 4. Then I'm going to say at A, which is 0 and 7. So my y is going to be 3 over 4x plus a 7. I don't need to use that formula since I know that this A is also acting as the y-intercept of my tangent. Okay, guys, so that is 2.1.5. All right, then 2.2. 2.2, they're telling us that two other circles are drawn or are given. Okay, one circle has a center K with this equation. The other has a center T, but with this equation as well. Determine the center and the radius of a circle with center K. And so what we normally do is we complete squares in this case. Okay, so I don't know how one would approach this, but I would always prefer moving the 12 that side. So I'll have x squared minus 6x plus y squared plus 4y is equal to 12. Okay, then let me just write to this side. This is 2.2.1. Okay, we said x squared minus 6x plus y squared, okay, plus 4y is equal to 12. Okay, guys, so we're gonna open two brackets. Okay. Just watch what I'm gonna do now. Okay, so we're gonna get x, and then let's keep the sign to minus, and then we get a half of 6, which is a 3. We square that. Okay, we know that 3 squared is gonna give us a 9. So we're gonna plus a 9 somewhere here. Then let's go to the y. Let's keep the sign, which is a plus. Then a half of 4 is 2. We square that. So we know 2 squared is 4. So I'm gonna put it that side, plus 4 as well. So which means I'm having x minus 3 squared plus y plus 2 squared is equal to 12 plus 9 plus 4. Is that true? Yes, which is a 25. So which means the coordinates of k are gonna be 3 and negative 2. I need to switch the signs inside the brackets. And then my radius will be the square root of this 25, which is 5 units. Okay, so guys, that is that, because this whole thing represents the r squared. So square root will be 5 units. So 2.2.1 has been answered. Then 2.1.2, sorry, 2.2.2. So we said this is 3 negative 2, and then our r is a 5. Then they want us to get the distance between the centers, K and T. The distance between the centers. Are these circles touching each other? No, we don't know. We don't know for sure. So we know that the coordinates of T are 12 and 10. And we know that the radius of the circle T radius is going to be 10 units. Ne? So what we need to know, use the distance formula so that we just save time. So KT is going to be the square root. I'm going to say 12 minus 3 squared plus 10 minus 2 squared. I'll punch that into the calculator. This is 12 minus 3. Come on. 12 minus 3 squared plus, that's 10 minus 2, which is a plus 2. And I square that, I'm getting 15 units. Okay. So answer for 2.2.2 is 15 units. That's from the distance formula. Now, they're asking us at how many points do the two circles intersect? So guys, remember, if you have two circles that are having K and T, if we get the distance KT, if this distance is equal to the radius of K plus the radius of T, then this is gonna be just touching at one point. Then if our KT, the distance we just found out, is greater than the radius, the distance of the radii, then which means they are not touching. Okay, and then if our KT is smaller than the radii, which means the circles are touching at 2 points. Okay, so we have our KT. Can we get the radius of K plus the radius of T? Remember we said radius of K was a 5, radius of T is a 10. So that is 15. So the two are equal. And we said for as long as they are equal, the circles are touching at one point. Therefore, the circles touch at one point. Okay, so at how many points do they touch? So we said 1 point. The motivation is going to be this. KT is equal to RK plus RT. There we go. So that would be our motivation, and that would be question number 2. Question number 3. This is trig. All right. Why are there a lot of marks? 24 marks up for grabs. Okay. Let's see if we can have it. Let's see if we can have these marks. All right. So I'm going to just erase this. Okay. Question number 3. Question number 3, they're telling us that we need to simplify without using any calculator. Simplify without using any calculator. So what I'm seeing is a big expression. The expression is sine squared, okay, of 360 minus x, minus, I'm having the cos of x minus 180 times the tan of negative x. And then I'm multiplying that by the sine of 90 minus x. And then this must be multiplied by the cos of 360 plus x. All this is being divided by the sine of 180 plus x. So guys, we need to apply our reduction formulas or reduction ratios within this question of 3.1. So what I'm seeing is that 360 minus x, maybe before we even start working out this, remember from our Cartesian, okay, we said we measure angles in the anti-clockwise direction. Those will be positive angles. And this quadrant is normally known as 90 minus theta. We normally call it 360 plus theta or x. Then this is 90 plus theta, or sometimes we call it 180 minus theta. This quadrant is 180 plus theta. And then this quadrant is known as 360 minus theta. Remember that in the trig ratios here are all positive. It's only the sine, only the tan, and only the cos. Okay. Now, when you look at 360 minus x, in which quadrant we find 360 minus the reference angle? It's in quadrant number 4. So in quadrant number 4, the only trig ratio that is positive is cos, which means sine is going to be negative. So I'm going to have negative sine x, but then I'm squaring that. Minus, I go to the top part. So we know that the cos of x minus 180 is just the same as the cos of 180 minus x, just for the cos. For sine and tan, we need to factorize out the negative sign, but for cos, it doesn't matter. So 180 minus is in quadrant number 2. And in quadrant number 2, it's only the sign that is positive. So that's going to reduce to negative cos x. Okay. Then I move on to, I can put this in brackets. I go to the next one, the tan of negative x. I can take the negative out so that it's negative tan x. And then the sine of 90 minus, this is a complementary ratio. So this is going to give me a cos of x. And then cos of 360 plus, remember 360 plus is in quadrant 1. And in this quadrant, all the trig ratios are positive. So that's going to be cos x. When I divide by cos 180 plus is in quadrant number 3. So in this quadrant, it's only tan that is positive. So this is going to reduce to a negative sign. Okay, if that is true, then what do I see? I'm seeing that this is gonna reduce to just a positive sine squared x. Okay, minus, I can change this to sine over cos if I want, but yes, I want. So then I'm still gonna keep that negative sign there, but I know that this negative and the negative will give me a positive. So cos x times sine x over cos x. And then I'm multiplying this and that. Let me just call it cos squared x and dividing it by the sine of x, negative. Okay, then I'm seeing that I have common things. This can cancel that. This negative and negative can give us a positive, no problem, but this sign can also cancel that sign. It's not a problem. So I have sine squared x. You said negative and negative will give us a positive, and then that's going to be cos squared x. From our identities, we know that sine squared plus cos squared, we must get a 1. Therefore, our answer is a 1. That is 3.1. And that's how you get all the 8 marks. Now, remember, marks will be awarded usually to the reductions that you do. Okay, let's say for a negative course, you could get a mark. For this course, a mark. That would be a mark. This would also be a mark. These are already 4 marks. You could get probably a mark for the positive sine squared. Those are 5 marks, 3 marks to go. The expansion of sine over cos could also be another mark. Those are 6. The simplification here, we can make this a 7, and then the last answer could be the 8 marks. Then let's look at 3.2. Another mega question, 3.2. They are telling us that if beta is between negative 90 and 270. So remember we said angles are measured to be positive in the anti-clockwise direction. Then if we follow the clockwise, then those would be negative angles. So if this is a 0, this is going to be negative 90. So in other words, we're looking at angles from this region, that same region. Okay, those are the angles we're focusing on for beta. So without a calculator, they want us to simplify this. Okay, so still we're going to apply our reductions, because this is a 45, this is a 405, a 300, and so on. But then in this case, we might need to use what we call the special angles. Okay. So what I'm going to see, I'm going to expand this, or I'll take out the negative first so that I'm just remaining with the sine 300. Cos 45 is just fine in this format. Then I need to see where I find this, and all right. So I'll have something like cos of beta plus 80 is equal to negative sine 300 times the cos of 45. And then I'm dividing this by the cos of 405. Now, when I apply my reductions, the question would be, where do I find 300 on Cartesian? So 300 is after 270, which means it's within quadrant number 4, where my reference or my reductions must be 369 or something. So that's going to be 360 minus an angle, give me 300 to be 60 degrees. Cos 45, we said we leave in it to it is. And then where do we find 405? That is after 360, so probably in quadrant number 1. So that's going to be 360 plus, is it a 45? Yes. So 360 plus 45 must give me this. This is equal to the cos of beta plus 80. All right. Then I'll go down and say my cos beta plus 80 is equal to, I can reduce this. I know that 360 minus in the 4th quadrant, sign is negative. Okay. So that's going to be negative, and then negative sine of 60. Cos of 45 is going to stay the same. And then in the 1st quadrant, when I reduce this, I'll get a cos of 45. All right. Then, I don't know whether making sense, but we move. So this is going to cancel that. This negative and negative, I'll get a positive sine 60. So I'll have the cos of beta plus 80. It's going to give me, what is it giving me? It's giving me the sine of 60. Remember, we don't have to use any calculators. Sine of 60, which is fine. Then, at this point, I need to find a way of expressing either cos in form of sine or sine in form of cos, whichever one would make sense for you. So I'll just replace this. So this is going to be a cos of beta plus 80. If I use the co-ratios or the complementary angles, I can use 90 minus 30 will give me 60. And then if I apply my cos, okay, so that's a cos of 90 minus 30. Does that make sense? No. Not at all, not at all, not at all. It can't be a 30. It has to be a 60. Okay, so that I can end up with a sine of 60. Okay, so then if that is true and I have the same ratios cos and cos, which means I can just drop them, and I have beta plus 80 is equal to 90 minus 60. We know that is a 30. And then move the 80 that side. So that my beta is 30 minus 80, which is negative 50. Okay, so where do I find negative 50? Negative 50 is most likely to be found in this quadrant here. Is there any other quadrant that's going to give me an answer within this range? Okay, I believe there is no other quadrant. So I'll leave it at that, guys. 7 marks. I don't know, but I feel like I've done what is enough for 7 marks. Because we expanded this, we reduced it, then we introduced the co-ratios, and yeah. Guys, if there's any other approach or any other value of beta, please advise me. I'm moving on to 3.3. Determine the following, or the value of the following, still without a calculator. So still we can use our reductions in this case. This is sine 49, this is 41. When I look at 49 and 41, it gives me 90. I'm going to use the complementary. So I can get the sine of 90 minus 41. Because 90 minus 41 gives me 49. Okay, I'm going to divide it by the cos of 41. So guys, in this case, do not change both, just change one of them. So it's going to make life much more easier. Okay, when I simplify the top part or when I reduce the top part, the cos sine. So this is a double angle, but it's a double angle of, not a double angle, it's a compound angle, sorry. It's a compound angle of sine. So if I call this my A, and then I call that my B, so I can reduce this to the sine of 85 plus 65. Okay, and I reduce this, simplify, what is 85 plus 65? Not times, plus, I'm getting 150. Okay, that's sine 150. Then we know that 150 can be found in quadrant number 2, where we have 180 minus. Okay, so sine of 150 This is question number 3.3.1. Is the same as the sine of 180, which angle do I subtract from 180 to 150? It's going to be a 30. So this will reduce to just a positive sine 30 because we said in quadrant number 2, in this quadrant, sine is positive. Now from our special angles and special triangles, the sine of 30 is going to be a half. Remember, this equilateral triangle 2 and 2. So you divide that into 1 and 1. That's a 60, that is a 60. We've divided the 60, now it's a 30. Okay, so this is a 1, this is a 2. When you talk of sine, it's the opposite of the hypotenuse. Okay, so that is 3.3.1. No, that is 3.3.2. What's the problem? I'm tired as early as this. Okay, 3.3.3. A half cos 15 plus root 3 sine 15. Guys, this question needs some bit of thinking. We need big guns for this one. So it's a half cos of 15 plus root 3 sine of 15. Okay, what I'm gonna do, I'm just gonna open this up so that I have a half the cos of 15 plus root 3 over 2 the sine of 15. I'm gonna take my chances and see if I'm gonna get something. So guys, when I look at my trig ratios, which angle from our special triangles is going to give us root 3 over 2? And it's going to give us a half. Root 3 over 2, and it's also going to give us a half. Okay, so remember, from this big triangle again, we're calling this a root 3. Okay, if this is a root 3, I know that root 3 over 2, which must also be the same as a half. If I use, let's say, the cos of 60, it's going to be 1 over 2. Okay, and then when I look at the sine of 60, it's going to give me root 3 over 2. So I'm going to use this triangle and I'm going to use this ratio. So where I see a half, I'm going to replace it with this. Where I see root 3 over 2, I'm going to replace it with that. So this is going to be cos of 60 and then cos 15 plus this, we said it's a sine of 60 and then the sine of 15. Boom. Then I have my compound angle. It's a cos cos, sine sine. So this is a compound angle of cos. So if I call this my A and my B, remember the sign here is a plus, which means it has to be a difference. Okay, so this is going to be the same as the cos of 60 minus 15. This becomes cos 45. And from our special angles again, is that triangle that talks about 1, 1, and then 2. That's a 45, and this is a 45. That's a 90. So cos of 45 becomes 1 over root 2. Use a calculator, you get root 2 over 2. And that would be using a calculator. Question said without. All right, so that is question number 3, guys. Let's move on to question number 4. Question number 4, they want us to determine the general solution. Okay, determine the general solution of this. Hey, gonna be trouble now. Yeah? He's saying the cos of 54 minus x is equal to the sine of 2x. If I expand this into 2 sine x cos x, it's gonna cause more troubles for me. I could do that, but I can find a simpler way of doing it without really causing any harm, without going through paragraphs and pages of answers. So like we answered there's a question that we answered where we changed, where we swapped the ratios and made them the same. Which question was that? Yeah, it was 3.2. You see this at this point where we changed this to just the same kind of ratio. It's the same thing I'm going to apply here for for question 4.1. And so what I can say is that when I look at cos, I think I can write a cos in terms of sine using the 90. Okay, so I'm going to say if I have sine of 90 minus the 54 minus x. Okay, because sine does not discriminate the signs. It's going to be the same as sine 2x. Okay. If I simplify this by opening what is in the brackets, I'm going to have 90 minus 54 plus x is equal to my sine of 2x. And I simplify this 90 minus 54. From my calculator, I'm having a 36. So that's going to be sine of 36. Why am I saying 360? I want to go for rotation. Okay, 36 plus x is equal to the sine of 2x. Now, since the ratios are the same, there are two things I just want us to keep in mind. Number one, I'm going to take this sine 2x, okay, to be more like my reference angle. Okay, let me do that, then I'll explain what I want to do. So 36 plus x is equal to the 2x. Okay. Then what I'm going to do, I'm going to take this to be positive, yeah? And then I'm going to solve for x in this case. Does that make sense? Which means I'm going to move the x this side so that my x is equal to 36 plus my k times 360. K is an element of integers. Okay, these are degrees. This is going to be my first solution. So what I'm saying, I'm taking this 2x to be my reference angle, which means this is quadrant number 1, where our sign is positive. Then in quadrant number 2, because that's where I find my sign to be also positive, I'm going to have 36 plus x is equal to, I'm going to have 180 minus 2x, and then plus k times 360. I'm just writing the solution. Just from here, if this is my reference angle, then I'll have my 180 minus theta in quadrant number 2, where my theta is 2x. I can't use 36. Can I use it? I can, no problem. I can use 36, but it's going to cause me troubles. So I would rather stick to the 2x here. Then I need to isolate everything. So I'm going to move the 2x this side. I'm going to move the 36 that side. So it's going to be x plus 2x is equal to 180 minus 36 plus k times 360. Now remember, when you're doing addition, switching, or subtraction, it's only the reference angle that is affected. This other element is not affected with addition and subtraction. So this is going to be 3x is equal to 180 minus 36. I'm ending up with 144. And then I'm plusing k times 360, and then I can divide through by x by 3, not by x. Okay, so divide by 3, and now the division affects that last part. So x is equal to 144 divided by 3 is getting 48 plus k times 120. K is an element of integers. So guys, that's my first solution. And then that was also my other solution. So that's how I would have approached question 4.1. Okay, because it's not a usual general solution question, but it happens. Ne? It's not in the normal, it's a new normal. All right, 4.2. 4.2, they're telling us that if 13 sine of x plus 5 is equal to 0, where our x is between 0 and 270, determine without using the calculator the value of sine 2x. So in this case, normally they will tell you with the aid of a diagram. Okay, in this case, they never said that, but it's 5 months. So guys, without a calculator, so don't be tempted to find the value of x using the arc sign and what. It's going to cause trouble. So with such questions, we are advising you to draw up a sketch. Okay, so 13 sine x, they said plus 5 is equal to 0. So step number 1, isolate this trig ratio. Move the 5 that side so that I have sine x is equal to negative 5 over 13. Move the 5 and then divide by 13. So if that is true, remember they're telling us that our x must be between 0 and 270. So when you're drawing your sketch, we need to also align it in the correct quadrant. So they said between quadrant 1, quadrant 2, and quadrant number 3. So from our simplified ratio, we see that the sign is negative. So this sign just helps us in identifying the quadrant. So we know that in quadrant 1, sign is positive. Quadrant 2, sign is positive. So the only quadrant that is left to focus on is quadrant number 3, where the sign is negative. Okay, so I'll draw my triangle in this sort of format. Remember, the height of the triangle must always be to the x-axis. You can never have it this side of the y-axis, always towards the x. Then I can replace my values. Remember, we said sine is opposite. Okay, opposite, this is the opposite, which is the negative 5. Our hypotenuse, here it is the 13. And then this distance, we need to find it using the theorem of Pythagoras. So r squared is equal to x squared plus y squared. We're looking for x. So which means it's going to be the square root of 13 squared minus 5 squared. Okay, so square root of 169 minus 25, which is a 12. Now, when you look at the square root of any answer, we always tell you it's a plus or minus 12. Now, this is where it plays out. When you look at this distance or this length, it's on the negative side of the x. So we shall label it as negative 12. And then this whole angle will be x, or even just this part inside alone. Now, this is our sketch or our diagram that we're going to use to answer the question that they need. Question is asking us to find the sine of 2x. So we know that sine 2x can be simplified as 2 sine x cos x. That's an identity. Then we're going to say 2 times. We know that the sine of x is this. So negative 5 over 13. Cos of x, we need to get it from here. So the cos is adjacent over hypotenuse. And that thing of written. So adjacent over, so that's negative 12 over 13. When you look at this, just simplify the numerators. This is 2 times 5 is 10. 10 times 12, that's going to be 120 over 13 and 13. That's going to be 169. Is it possible to simplify that? Not really. Just leave it like that. Now the question is 5 minutes. Some marks are going to be awarded just for using the correct sketch, the correct diagram. This answer of yours might just carry probably 2 to 3 marks, but some marks are going to be allocated there. Then 4.3, they want us to prove the identity. 1 plus sine 2x over cos 2x is equal to this, 7 marks. Wow. I don't know. Looks, the marks are scary. Eh? Feels like, no, it's a huge question. Let's see. Let's hope we get the answer. Because such questions are a headache. Eh? You're given the question, and then you're also given the answer. So if you fail to get it, you know that, oh, those marks are gone. So in this case, remember, when you're proving such questions, it's your choice to start with any side and move towards the other side. So I'm gonna start from the right-hand side. I don't know, for this particular question, because I see this, I feel it will be much more easier to work with this and move towards the left-hand side. So I'm gonna say my right-hand side, I have cos x plus the sine x over cos x minus sine x. So what I'm going to do, I'm gonna multiply by the opposite of this. So I'll say cos x plus sine x over cos x plus sine x. Now, the reason as to why I'm using the same bracket is because if I cancel it, I'm going back to the original thing. So I'm introducing something just to help me out in simplifying the question. Okay, so that is in brackets. So when I open this up using my FOIL, cos and cos is going to give me cos squared x. Cos and sine, I'm going to get cos x sine x. And then I'm going to have another cos x sine x. And then I'm going to have my sine squared x. At the bottom, one bracket is negative, one bracket is positive. It's more like a difference of two squares. So that is cos squared x minus, okay, let's go. Let me not skip. People will be asking, why are you running? Okay, so cos and cos, that's going to be cos squared x. Cos and sine is going to be plus cos x sine x. And the negative sine and cos is going to be negative sine x cos x. The negative sine and positive sine is going to be negative sine squared x. Okay, now it's time for me to simplify. So from the top part, I can see a cos squared x. So this and this is going to give me 2 sine x cos x, and then I have my sine squared x over, this is going to cancel that, and I'll be left with cos squared x minus sine squared x. Then we know from our identities that cos squared and sine squared must give us a 1. Okay, so that's going to be like 1 plus 2 sine x cos x over, when I simplify this from my formula sheet, I can see that this is another expression of the double angle of cos. So that's going to be cos 2x. When I look at this top part, it's the double angle of sine. Okay, so that's going to be 1 plus sine 2x over cos 2x. There we go. This is equal to the left-hand side. And then I'm done. So that is how I would have gone about with that question. Okay, I'm not going to comment further to say whether it was hard or easy, but that is the approach. Question number 4.4. If sine 39 is equal to P, okay, determine in terms of P, all of this. So still with this question, I don't know, I feel like you can still use a simple sketch if you don't mind. So let's call P to be P over 1. And then this triangle can be right angled. If that is a 39, this is a 90. What angle is that? So what is 90 minus 39? I'm getting a 51. Not a big deal. Sine is opposite over hypotenuse. Okay, so this is our opposite, this is our hypotenuse. So which means this remaining side will be 1 minus p squared from your Pythagoras. Okay, then 4.4.1, I need to find the sine of 129. So 129 can be found in quadrant number 2. Okay, in quadrant number 2, that's why I have 180 minus theta. So which means I need to express this 180 minus something so that there is an element of a 39 attached to it. Alternatively, if I don't work it that way, we know that in quadrant 2, it's also the same as 90 plus theta. Okay, I don't know which one, but I feel like the 90 can be easier. So that's gonna be 90 plus a 39. Okay, 90 plus 39. We know that this is gonna reduce to something like cos of 39. When I reduce that, then I can come to my sketch. I know that cos is adjacent over hypotenuse. So the answer must be 1 minus p squared. So that is my answer for 4.4.1. And as much as the question is 3 marks, you could be given a mark for just drawing this sketch and finding the missing sides before you get the answer. Okay. This answer could be a mark, and then other mark could be for the sketch. Then let's go to the turn 3-2-1. So 3-2-1, 3-2-1, 3-2-1 is in quadrant number 4. Quadrant number 4 is the same as 360 minus something. Okay, what is 360 minus 3-2-1? That's a 39. Okay, 360 minus 39, I'll get my 3-2-1. And in quadrant number 4, we know that tan is negative. So this is going to be negative tan 39. And then I'll have to apply the ratios from that triangle. That's a negative. We know that tan is opposite over adjacent. So it's going to be negative p over square root of 1 minus p squared. So that is going to be my answer. Then 4.4.3, sine of 7/8. So how does 7/8, because 7/8 is an acute angle, how does it relate with the 39? Is it a multiple? Is it a vector? I mean, what's going on there? So what I'm seeing is that if I get 2 times 39, I'll get my 78. Okay, so this is a double angle of 39, which is the same as 2 sine 39 and then cos 39. Then I'll go back to my triangle there. That is 2. You know that sine of 39 is a p. And then the cos of 39, we said it's the square root of 1 minus p squared. There we go. So that is what one would have done for question number 4. Question number 5. Question number 5. Okay. So with question 5, they are telling us that in the diagram below, O is the center. Okay, that's a keyword of the circle, and L is a point on the circumference, and then the diameter PQ. This is also relevant. So that's a PQ diameter, and it makes 26 degrees with a tangent. Okay, we also have a tangent. Good. R, L, M. That's the tangent. Then N is a point on the lower part. Where is N? Oh, here it is. Okay. That is the information. That is the drawing. And they want us to get the size of OLM. So OLM. In other words, they are asking for this angle here that the radius makes with the tangent. Does that make sense? Yes, because we know that OL is a radius. So what angle is that? So what I can say is that OLM is going to be 90 degrees. Okay, OLL is 90 degrees. That is the statement. The reason is going to be tangent is always perpendicular to the radius. Some people call it tan radius, tan perpendicular to the radius. Then they want us to get O2. Now, since we've said that this is a 90, then what is this O2 here? So from the triangle LOM, okay, so it will be 90 plus 26 plus O2 must give you 180. Oh, since you know that this is a 90, then these other two must also give you a 90. So it's as good as someone saying 90 minus 26. So our 90 minus 26 is 64. So which means O2 is 64 degrees. You can say angles in triangle OLM or LOL in whichever format. Okay, so that is the explanation. Then they want us to get P. What's happening with P? It's a different. Okay, so P is here, is the angle at the circumference. What we just found was the angle at the center, the 64. So what normally happens that these questions are structured in a way that whatever you get in the previous question must always guide you towards answering what is coming down, okay? So if this is a 64, we can see, okay, I don't know if people can see that the same segment or the same chord that is creating 64 is the same chord that is creating this. Just that O2 is at the center, P is at the circumference. So we apply angles at the center. Must be twice angles at the circumference. So since we have the angle at the center 64, which means P must be a half of 64. So which means P is going to be 32 degrees. The reason angle at the center is equal to twice angle at the circumference. Okay, so that is P, which is a 32. Then they want us to get Q1. Q1. How many marks? Which is 3 marks. Q1, Q1, Q1. Does it make sense? Make sense. Let's see. Let me change this to a green. Okay, this is the angle that they want. All right, shouldn't be a problem. So I'm gonna say from LOQ. Okay, from LOQ. If I focus on this triangle, okay, I know that this side must be the same as this side, which is radii. Okay, so I'm gonna say OL is the same as OL is the same as OQ. The reason radii, and if that is okay, so P is here, is the angle at the circumference. What we just found was the angle at the center, the 64. So what normally happens that these questions are structured in a way that whatever you get in the previous question must always guide you towards answering what is coming down, okay? So if this is a 64, we can see, okay, I don't know if people can see that the same segment or the same chord that is creating 64 is the same chord that is creating this. Just that O2 is at the center, P is at the circumference. So we apply angles at the center. must be twice angles at the circumference. So since we have the angle at the center 64, which means P must be a half of 64. So which means P is going to be 32 degrees. The reason angle at the center is equal to twice angle at the circumference. Okay, so that is P, which is a 32. Then they want us to get Q1. Q1. How many months? Which is 3 months. Q1, Q1, Q1. Does it make sense? It can make sense. Let's see. Let me change this to a green. Okay, this is the angle that they want. All right, shouldn't be a problem. So I'm going to say from L or Q. Okay, from L or Q. If I focus on this triangle, okay, I know that this side must be the same as this side, which is radii. Okay, so I'm going to say OL is the same as OL is the same as OQ. The reason radii. And if that is true, then I have an isosceles triangle. So if this is X, then this must also be X. L is 3 and 4. So which means I'm going to get 180 minus 64. 180 minus 64. Okay, it's fine. Let me just do it. Let me use that approach. So I'm saying OLQ. OLQ must be the same as Q1. Reason, angles opposite sides. Then which means if I have twice of Q1 plus 64 must give me 180 because of angles in triangle LOQ. I can move the 64 that side. Twice Q1 is going to be 180 minus 64, okay, which is 116. And then I'll divide both sides by 2, which means my Q1 is going to be 5.8. Okay, so guys, that's how I would have obtained that angle. Alternatively, okay, when you look at Q1, Q1 is exterior to the triangle LMQ. So one can first of all tell us that the angle L5 is a 32 because of the tan chord. Yeah, we must use the tan chord somewhere. If this is a 32, then Q1 must be 32 plus the 26, which must also give us 58 degrees. Reason, exterior angle, triangle L and Q. As this would have been the shortest way, but nevertheless, still have the same answer. So use whichever format you use. Okay, guys, that is question number 5.1. No, that's 5.1. Let's move on 5.2. They are telling us that in the drawing, in the diagram below, A, B, C, and D are lying in the circumference of the circle. Can we prove that C2 is the same as B minus A1? This is serious now. C2 is the same as that minus that. Okay, let me do this. I'm going to start by letting, what can I let? I can let my D1 to be X. Okay, if I call that X. And then I'm going to let my A1 to be a Y. Okay, so that is a Y. Then what I know is that ABCD is a cyclic quadrilateral, okay? Which means that B is gonna be the same as X. Reason? Because of exterior angle of a cyclic quadrilateral, ABCD. Okay, so calling this X. This same as that. Then if that is true, I can try to find D2. D2 is gonna be 180 minus X. Either angles on the line or opposite angles of the cyclic chord. Okay. Then from there, I could go on and try to find what my C2 is from triangle. So I'll say that from triangle ACD, if I have C2 plus my Y plus my D2, which is 180 minus X, this must give me 180. And I'm gonna move everything that side and leave C2 on one side. Oh, this one is gonna be angles in triangle ACD. So C2, when I move the 180 that side, it cancels out, move the X that side, it will be just X. And then the Y is gonna be minus Y. Okay. So that is my C2. Then when I look at what is B minus A, I'll say, but B minus A1, what's my B? Say my B was X minus our A1, which is a Y. So therefore, C2 is the same as B minus A1. Okay, guys, we could do that. Or alternatively, someone would have used the letters the way they are, D2, A1. I find this much more simpler, much more easy. Guys, you are allowed to do that. Remember, in Euclidean geometry, you're always allowed to construct and add stuff as long as they help you in answering the questions. Okay, that is question number 5. We move on to question number 6. They're telling us that in the diagram below, O is the center. Okay. We have A, P, B, a point in the circumference of the circle, arc AB subtends A or B at the center and APB is at the circumference. Can we use the diagram to prove that A or B is twice? Okay, guys, with this question, you need to do some constructions. Okay. You can just connect this. Okay. And then can label this as 1 and then label this as 2. So we know that P is the same as P1 plus P2. Then what we need to also state is that OP is going to be the same as OA, which is going to be the same as OB. The reason, those are radii of the same circle. And if that is true, which means that this P1 is the same as this angle. Okay, so I'm going to say A is going to be the same as P1. Reason, angles opposite, equal sides, because POA is an isosceles triangle. This is the same as that, same as that. So the same story happens with B, which means B is the same as P2. Angles opposite, equal sides. Wow, okay. So we're calling this a P1, we're calling this a P2. Now, can we go on and find the size of POA, this angle here? So we're saying that POA is going to be the same as 180 minus twice these angles, twice P1. Okay, reason is angles in triangle POP. When you add this P1 and this P1 and then the O, you must get all of that for you to get the O, this one. Then I'll do the same thing on this other side, that POB is going to be the same, 180 minus twice P2, still the same reason. Angles in triangle POB. Then, if I try to find, okay, the entire size of this, it will be as good as me adding up these two. So that I have my, how will I even put it? Okay, so I'll say when I add the two, POA plus POB. Okay, minus 2P1 and then minus 2P2. Just this sum of this. And then for me to get my A or B, okay, A or B is going to be 360 minus whatever I got here. This is 360 minus 2P1 minus 2P2. Reason is going to be, it's a revolution. Or angles at a point. Must add up to 360. So this plus what I got must give me 360. Open that. I'm going to have 360 minus 360 plus, and then a plus. So I'll factor out the two, P1 plus P2. So 360 and 360 will die out, and then I'll be left with twice P1 and P2. And remember what we said in the first statement, that P is the same as P1 plus P2. So therefore, A or B is twice P. But we know that P, and say that A or B is twice APB. Just leave it like that. So guys, that's how the proof could be done. Okay. There could be other simpler ways of doing it, but this is what I feel comfortable with. Then 6.2. In the diagram below, F is the center, okay, of the center, and AC is the diameter, right? AC is produced to K such that B1 and B2 is 122 and K is 26. All right. Can we show that BK is a tangent? So for us to show that BK is a tangent, number one, we don't have any radius around. We need to apply the term code format. So if I can prove that B2 is the same as A, then that is enough for me to make this BK a tangent. So what I can start with, I'll have to find the size of what? I can start with B1. I don't know, whichever way you want to start. So I'll say B1 is a 90. Remember, AC is the diameter. So the angle that is in the opposite end, the diameter will be 90 degrees. Reason, we are saying angle in a semicircle. Okay, so if this is a 90, then what is our B2? B2 is going to be 122 minus 90. So B2 is a 32-degree complementary angles. Not complementary as such, but the remaining part. So we're saying this is a 32. Then I can say that from triangle, which triangle ABK, from triangle ABK, I can look for the missing angle A using the angles in the triangle. So what I'm saying is I'll have A plus 122 plus the 26 must give me 180 degrees. Angles in triangle ABK. Okay, so if that is true, then my A is gonna be 180 minus. Remember, I'm looking at this entire angle. I'm looking at this entire angle. So this triangle is what I'm focusing on. So what is 122? That's gonna be 148. So 180 minus 148, I'm getting a 32 perfect. So remember what we said, if A is the same as this B2, then it's a term chord. So therefore, BK is a tangent, or we can say since A is the same as B2, which is equal to 32, therefore BK is a tangent. And the reason is going to be the converse of the term chord. Or you can just tell us term chord. Converse of the term chord. Okay, that is question number 6. Question number 7. Telling us in the diagram or in triangle ABC below, D here points on ABs respectively such that D is parallel. Okay, can we prove the theorem that states that AD over BB same as that over that? So still, even in this question, guys, we need to do some bit of construction. Okay, so you can always extend this so that it's a perpendicular. You construct this so that that is also perpendicular. And then you also have to draw lines to connect B and E. Then you also need to connect C and D. Now, after doing that, we can label this to be a K and then this to be H. The height H and then the height K. Then what I can do is that I can find the ratio of the area of ADE over the area of DEB. Okay, we know that area is normally given as a half. My base is going to be the AD. Okay, so we're talking about ADE. Okay, so I'm focusing on this height, which is K. And then DEB. So the same triangle having the same height. So it's going to be a half. I'm going to take this to be my base, which is DB, but with the same height, which is K. So the K and the K will cancel, a half and a half will cancel, which means AD is going to be DB. So the rest is AD over DB. Then I'll move on and talk about the area of ADE. Okay, divide by the area of DEC. Talking about ADE again, but this time around we're talking about DEC this side. So I'm saying a half, instead of using the AD, I'm going to focus on the AE. AE times my height in this case, which is H, over half, in this case, the same height H, but with the distance EC. So EC times H. H cancels, a half cancels. So I have AE over EC. But one thing we know is that the area of DEB is the same as the area of DEC. Let me just highlight this separately. Okay, so it's saying the area of DEB. Okay, the area here must be the same as DEC. The area of this side. That's what we're saying. So which means if we get the area of ADE over the area of DEB, initially. ADE, PE must give us the same ratios as area of ADE over the area of PEC. Okay, then I can just equate the two ratios. So AD over DB is equal to AE over EC. So guys, that's what they wanted us to prove. So what we mark usually will be the constructions you make, the labeling, and how you break that up. 7.2. In the triangle DXZ, AC is parallel to this, BP is parallel to that, and it's drawn the intersect AC at B. Okay. Can we prove that BC over YZ is the same as DA over that? So when I look at this, I have quite a lot of triangles. I have this triangle that I can use. I have the big triangle that I can also focus on. But I also have this triangle in this sort of format, in the first kind of format. Okay. So what I'm gonna say is that from triangle DXY, okay, from triangle DXY, DX, and then Y. This is our focus. DXY. So what are we saying? We're saying that AD, okay, if you get the AD over the DX must be the same, with respect to X, must be the same as DB over the DY. The reason is going to be proportionality theorem, because AC is parallel to XZ. Proportionality theorem because of that, okay? Then if that is true, then I can look for another triangle, which is DYZ, the one that I was looking at initially. So from that triangle DYZ, I can see that BY, what should I use? Okay, it's fine. Just use BY, no problem. You can see that BY over my BD. Does it make sense? BY over BD. No, it's not going to make sense for me. Let me not look at it that way. I can maybe come that side, but let me just focus on this where I have my YZ. Okay, so this divided by my P. Let me switch it around and say that my PZ over my YZ is going to be the same as, since I've used PZ, then I'm going to use BD over this whole distance, which is dy. Okay, it's going to be the same reason, proportionality theorem, because which lines? PB is parallel to DZ. Okay, and I need to compare this and this. I have a DB, I have a DY. I have a BD, I have a DY. So which means my AD over my DX is equal to, so I'm equating this with this, the same PZ over YZ. Are we there? So we have a BC over what he said. We have a PZ. Okay. We have BA, we have X. Okay. So these other parts are fine. Let's now focus on the PZ and BC. So how does PZ and BC relate? So PZ is here. This is a BC. Now, one thing we need to remember from our quadrilaterals, let it be a rectangle, let it be a square, let it be a palm, a parallelogram, even a rhombus. Okay? I'm just focusing on shapes where the opposite sides are parallel. Okay, so if this is parallel to that one, this is parallel to that one. In other words, you have two pairs of parallel sides. In most cases, the opposite sides will be equal. Okay, so we can call this a parallelogram, or we can refer to it as a rhombus. It can be referred to as a rectangle because the opposite sides are equal. So we can say that since PZ is parallel to BC, and then PB is parallel to CZ, which means PZ is equal to BC. Hence, our BC over YZ must be equal to AD, and DA is the same thing. Is equal to DA over DX. Then we're done with that proof. Okay, then question number 8, the last one, final. Okay, so in the diagram below, NPQR is a cyclic quadrilateral. Okay, with S that is drawn, it's not a center, but it's on the chord PR. N and S are joined. Okay, R and S is the same as P and Q, which is equal to X. 8.1. They want us to prove that NSR is the same as NPQ. This is NSR. Then we need to choose the NPQ. It's a different NPQ. This is N and Q, something like that. Can we find any similarities in this? So what we can see is that there's X there and then there's X. So I'm gonna say that P and Q is the same as R and S. Okay, P and Q. So this angle is the same as R and S, which is X. And the reason is given to us. They told us that that's X and that is also X. Then, what else do I see? Which other angles? When I look at R1 and Q1, sorry, Q2. Okay. When I look at this, I can see that this is going to be the same as that. So saying Q2 is the same as R1. Reason, angles in the same segment. Okay, angles in the same segment. And then automatically we can say that P is the same as S1. And then that is the remaining angles of the triangle. So now we have three facts. Remember, these three lines represent, or they represent similarity. And for similarity, normally look at the angles of the sides being in proportion. But in normal cases of the 12, it's normally the angles that we look. So we're gonna say, therefore, NSR is similar to NPQ because we looked at the angles. So angle, angle, angle. Some people prefer to use the triple A, no problem. So 8.1 has been taken out. Let's look at 8.2. 8.2, they're asking us to prove that NQR, do I have enough colors? Let me use big blue. NQR, this triangle. That triangle is similar to another triangle. Let's go for green. NPS. We need to find what is common between these two triangles. Okay. Now, what I can see, let me just do it again. So I need to look for what is common there. One thing we know, P1 is going to be the same as Q1 because of the same segment. Okay, so that's what I'm going to start with. P1 is the same as Q1, angles, same segment. Okay, those segments subtend equal angles, something like that. So P1 is done with Q1. Then what can I see? When I look at this angle here, there's X and then there's N1 for this small triangle. Okay. And then when I look at this angle, I can also see the same thing. So I'm going to say that R and Q is the same as S and P. Okay, because both of them are having X plus N1. You can say given, no problem, because it's already there in the drawing. Then automatically, for as long as we have that, which means the whole of R, that is R1 plus R2, is going to be the same as S2. The reason is going to be remaining angle, the triangle, remaining angles of the triangle. So we have our three effects. Then we can draw the conclusion that therefore triangle NQR is similar to triangle NPS, angle, angle, and angle. So guys, that is the end of that paper, 130 marks. Good luck as we wait for our results now. Thank you very much. Let's meet in the next